Can thermal conductivity be measured experimentally? Have you ever wondered how scientists figure out how well materials conduct heat? It might sound complicated, but measuring thermal conductivity is something that can be done with various methods. Thermal conductivity is simply a way to describe how well a material can transfer heat through conduction. To measure this property, scientists apply heat to a sample and see how fast the heat moves through it. There are two main types of methods: steady-state and transient techniques. Steady-state methods keep a constant temperature difference across the material. One popular example is the guarded hot plate method. In this method, a sample is placed between two plates that are at different temperatures. Once the heat flow stabilizes, scientists can measure how much heat is moving through the sample. On the other hand, transient methods involve applying a heat pulse or changing the heat source and observing how the temperature changes over time. A common transient method is the transient hot wire technique. In this case, a thin wire is heated electrically inside or between the samples. By tracking how the temperature rises over time, researchers can calculate the thermal conductivity. Another transient method is the transient plane source technique. Here, a sensor is placed between two halves of a sample. The sensor heats up, and the temperature change is monitored to determine thermal conductivity and related properties. For very thin films or small samples, scientists use specialized techniques like the 3-omega technique and time-domain thermoreflectance. These methods involve applying modulated heat and measuring temperature changes through electrical signals or laser reflections. This allows for measuring thermal conductivity even in very thin materials. Each method has its pros and cons. For instance, transient methods are often quicker and can be used for various materials, including solids, liquids, and pastes. Steady-state methods may be simpler but usually take longer to get results. Measuring thermal conductivity is essential for many practical applications. Engineers need this information for designing materials and systems in areas like electronics cooling, insulation, and energy efficiency. Knowing how heat moves through materials helps optimize thermal management in various technologies. In short, thermal conductivity can indeed be measured through carefully designed experiments. The choice of method depends on the material and the specific conditions of the measurement. Understanding these techniques is a key part of applying the principles of thermodynamics to real-world materials and technologies.